Welcome to the Explainer. Today, we are going to get into the nitty-gritty of how AI assistants actually get their real-time smarts. We're breaking down a super powerful framework called Retrieval-Augmented Generation, or RAG, piece by piece.
Okay, so let's kick things off with a scene that I'm sure is familiar to pretty much everyone. You hop onto a powerful AI, you ask it about some big news story that just broke, expecting, a solid, up-to-the-minute answer.
And what do you get back? Something like this. I am unable to provide comments. I do not have any information regarding the dismissal and rehiring of OpenAI's CEO. Ugh, sound familiar? It's that classic, super frustrating dead end.
So why does this happen? Well, it's because a standard large language model has this one big problem. Its memory is basically frozen in time. Its knowledge is totally static, based only on the data it was trained on. And that data could be months or even years old. It's kind of like asking a historian to comment on tomorrow's news. They just don't have the data yet.
But what if we could totally smash through that limitation? What if we could give that LLM a direct line to a library that's updated every single second, a constantly evolving authoritative knowledge base in real time?
Well, that is exactly what Retrieval-Augmented Generation, or RAG for short, is all about. It's this brilliant framework that basically gives these powerful models a fresh, constantly updated memory. All right, let's dive in and see how this whole thing works.
Okay, this diagram might look a little complicated at first glance, but don't worry, it's our roadmap for the next few minutes. It shows the whole RAG process from start to finish. Think of it like this. We're going to see how new information gets prepared and stored, and then how your question gets a smart, relevant answer. We're going to break down every single step.
So, the whole process is really split into two main pipelines. First up is data ingestion. This is all about teaching the system new things, how we prepare and feed it all that fresh knowledge.
And it all begins with the raw materials. We're talking about your external documents. This could be pretty much anything. PDFs, dense research papers, internal company wikis, websites, medical reports, you name it. This is all the good stuff, the fresh knowledge we want our AI to learn from.
Now, you can't just throw a 100-page PDF at an LLM. They have a limit to how much info they can look at once. It's called a context window. So the very first step is to break these big documents down into smaller, bite-sized pieces we call chunks.
And this step, chunking, is absolutely crucial. Just look at the difference here. If you try to process a whole document without chunking, the quality is just poor. You exceed the context limits, it's super inefficient, but with chunking, you preserve the actual meaning, you stay within the limits, and you seriously reduce the computational load. It's a no-brainer.
Okay, now for what feels like a little bit of magic. We have to convert all this text into a language that machines can actually work with. And what's that language? Well, it's numbers.
It's really that simple. Humans understand text and meaning, but machines, they get numbers and vectors. That's the fundamental gap we have to bridge.
And the way we do that is with something called an embedding. Think of an embedding as a numerical fingerprint for a piece of text. It's a vector, which is really just a long list of numbers, that captures the semantic meaning and context. So a question like, how does CNN detect tumors, becomes a string of numbers. This is how the machine understands not just the words, but how they relate to each other. It's super powerful.
So once we have these powerful numerical fingerprints, where do we put them? They get stored and organized in a very special kind of database.
Yeah, a vector database. You've probably heard of some of the popular ones, like Chroma or Pinecone, which is cloud-based. But honestly, for a lot of real-world projects, FAISS is an absolutely fantastic choice. It's fast, it's free, and you can run it right on your own machine. Okay, recap. Our knowledge base is built, indexed, and ready to go. So now let's flip over to the second pipeline, retrieval and generation. This is what kicks in the moment a user asks a question. And believe me, this is where RAG really starts to shine.
So a user asks a question. First thing that happens, that question gets turned into the exact same kind of embedding vector we just talked about. Then the system does something called a semantic search. It takes the question's vector and compares it against all the chunk vectors in our database to find the closest matches. And here's the key. It's not a keyword search. It's searching for meaning and context. It's looking for the chunks that are most conceptually similar. And this is the augmented part of Retrieval-Augmented Generation. We take those top matching chunks we just found, and we use them to enhance or augment the prompt we send to the LLM. You can think of it like we're giving the AI a cheat sheet with all the relevant facts it needs to answer the question perfectly.
So the system literally builds a brand new context-rich prompt. It takes the user's original question and tacks on the actual text from those chunks it just retrieved. It's basically saying, hey LMM, here's the question and here's the exact information you need to answer it. Go.
And here's the payoff, right here. The before and after is just night and day. Without RAG, you get the classic, I don't have information on that. But with RAG, because the LLM has that fresh context we just gave it, it can give you a detailed, nuanced, and most importantly, grounded answer based on actual, up-to-date information.
Okay, so this is cool for answering questions about breaking news. But where is RAG being used in the real world? Why should you actually care about this?
Well, RAG is a total game changer for so many things. Imagine enterprise knowledge systems, an AI assistant that can instantly search through all of your company's wikis, emails, and customer data. Or how about intelligent search engines that find what you mean, not just what you type? It's also huge for dynamic fields like finance or healthcare, where an AI needs to be up to date in real time without constant, expensive retraining.
So here's the bottom line. RAG fundamentally changes what an LLM is. It turns them from these static, know-it-all models with outdated information into dynamic systems. It's like giving them a long-term memory that you can update instantly, on the fly.
And that leaves us with a pretty fascinating thought to wrap up on. RAG is incredible for what it does today, grounding AI in facts. But is it possible that this is just the first step? Could RAG be the key to building systems that don't just generate text, but that can actually understand context and learn from the world as it changes?